We've already introduced the fact that wireless signals are analog signals. And so let's take a look at those signals and see if we can then use this information that we'll learn in this video to figure out how we're going to convert it from analog to digital signals for computers, because computers only know 1 and 0. Well, there are 3 characteristics we need to know about: amplitude, frequency, and phase. Amplitude, the strength or height; frequency, the number of peaks per second; and phase, the location of the peaks relative to a point in time. Well, let's look at them here on our chart. Amplitude has to do with the height of this wave. How big a wave am I making? The more energy I put into making the wave, the higher the wave will be. Less energy, of course, lower it'll be. So this is one wave here. Actually, from here to here and back up to here is one cycle. And so this is the amplitude. The frequency is how many of these cycles every second am I going to do. I can have a very low number or a very high number, as you can see here. So, of course, I can have an infinite number of variations between them. And finally is the phase, which is a little more difficult to understand and to explain. In this case, I have one cycle which goes from 0 here up to the peak, down to this trough, and then back up to 0 again. This is one cycle. And you can see here that if I give, let's say that I set this period of time as 1 second. Well, you can see that this wave didn't start until about maybe a quarter of a second later. And so its peak is at a different point in time than this peak. So the phase has to do with time and the points in time at which this cycle is going. And so this characteristic I can also use. And we'll talk about how we convert these in the next couple of videos. But we have these 3 properties: amplitude, frequency, and phase. You may be asking about this guy here, wavelength. The wavelength is the distance, the physical distance between one trough and another trough, or one peak and another peak. And the wavelength is really just a function of the frequency. In fact, it's an inverse function of the frequency. If I have a low frequency, I have a very long wavelength here. If I have a high frequency, you can see I have a very short wavelength. And so we don't consider wavelength a separate property, because it's just an inverse function of the frequency.